I'm Soundarya, working as assistant professor in CSM department in Mlritm college. Today we are discussing about levels of data abstraction and data independence in DBMS. Okay, first one, why the data abstraction is in DBMS and what are the uses in data abstractions in DBMS. Let's check it. So this concept is very important in the DBMS because the data abstraction is the process of hiding unwanted data and irrelevant data from end users. So which is useful to the users? We are providing the data to the database while they are accessing from the database, which is not related, unrelevanted, otherwise which is not useful for the users. We are hiding the data by using of the data abstraction. So it helps to store the information in such a way that end users can access data which is necessary. The user will not able to see what data is stored and how the storage is in the databases. Now, the database abstraction hides unwanted files, unwanted data, irrelevant data to the user. It shows users only relevant data, which is necessary to the users. It keeps safe by hiding how and where the data is stored. Abstraction simplifies access while maintaining the data security and efficiency. By using of the data abstraction, we are also providing the security. For example, when we are doing shopping, either it is online shopping and offline shopping, we are buying the clothes. The user sees only the texture of the cloth and price, color, size, like this information. The user don't want to check and don't want to need about the entire product details, the particular cloth. Okay. Now, the levels of data abstractions in the DBMS. There are the three levels in data abstraction. They are, first one is physical level, or we can also call it as a internal level. Okay, physical level or internal level, both are same. And second one is a logical level or conceptual level. We can call either it is a conceptual level or the logical level. The last one is a view level or external level. We can call anyway. The first one is a physical level or internal level. Second one is a conceptual level or logical level. And third one is a view level or external level. Let's take in detail about these three levels. So this is the structure of levels of abstraction in DBMS. Look at the first one. So this is the database where the data is stored here, data storage. So we are having the three levels. That is, the first one is physical level or internal level, and second one is a logical level, or we can call it as a conceptual level, and third one is a view level, where there are the complete view level. This is, we can call it as a external level. Okay, the user can see this data, the user cannot see this data, so the entire data is hide. Okay, now physical or internal level. It is a low level of the data abstraction. It defines how data is stored in the databases. It defines the data structure used to store data and methods to access data in the database. We can store data and we can also use the data methods in this particular database. It is very complex to understand, hence keep the hidden from the users. Because it is very complex, so user cannot understand, which is familiar with the DBMS, they can understand very little bit, but which who are not relevant about the DBMS concept, they can't understand. Okay. And next, the DBMS administrator, that the database administrator, decides how and where the data is to stored in the database. This particular data administrator, that we can call it as a DBM, this database administrator can decide how the data is stored in the database, where we have to give the storage and allocation, everything will be handled by DBM. And physical level deals with the actual storage details like data organization, disk space, allocation and data access method. Okay, we can also give the data organization, disk space allocation and data access in the DBMS. So next one is a logical level. We can also call it as a conceptual level. This is an intermediate level presented in DBM, database abstraction. That is a high level of the physical level abstraction. Physical level concept. So it defines data presented in the database and their relationship between them. What the data is presented in the database, it can be handled, the data, and what are the relations having in the database. Okay, it is very less it is less complex as compared to the physical level. Comparing to the physical level, logical level or conceptual level is very easy. Programmers can generate works at this level and depends on the data structure of the table, but the relationship and their constraints is deciding in this level. So this particular level, it can be deal what the data in databases and what are the relations it is having, and the programmers generally works on this level, and it is depending on the data, the structure of the tables and relationship of that particular tables, and what are the constraints rules or instruction handled by this level. The next level is a view level or external level. So this is the highest level in the data abstraction. Okay, so it means the first one is a physical level, top of that one is a conceptual level or logical level, and the last one is a view level or external level. Okay, and there are the different levels of view. Each view benefits only the part of whole data is required to the user. So in this particular view level, there are so many viewers are there, end users. So which is required to the particular user, we are providing that data to the users to access. Which is not relevant, which is not useful to the particular end user, we are not providing that data in this particular stage. This level depends many views of same databases for the simplicity of the view of users. This is the highest and easiest to understand the users. So this is very easy comparing to the remaining two levels, that is a physical level as well as a logical level data abstraction. Okay. The next concept is data independence. So what is the data independence in the DBMS? So general meaning of the independence is we are not depending on any others. Okay. So data independence is a fundamental concept in the database management system that refers to able to modify schema at one level of the database without affecting the schema at the next level. So whenever you are changing data in the physical level or logical level, it may not affect to any other level. If suppose I am changing data in the physical level, it cannot affect it to the logical level. Whether I am changing the data in the conceptual level, it is not affected to the physical level. Okay. This concept is ensured that changing how the data is stored or structured internally don't impact to the how users or application access and interact with the data. So whenever you are changing data, it cannot be impacted to the user level also. That is a view level or external level. So why data independence is important in the DBMS? So it can be reduce the maintenance. Okay, the developers don't need to update application every time the data structure changes. Whenever it can be changes the data structure. Suppose I am while we are creating the table, the 3 by 3 columns are there or rows are there. So when I am adding this particular column to the presenting table, it may not be affected to the physical level as well as the logical level, but the developer need to update application every time. No need to update the every time the data structure changes. When if suppose I'm adding the column, otherwise I'm inserting the rows, it cannot be updated every time. So maintenance is not required for the every time when the data structure is changes. And increases the flexibility. Very flexible. The database can reorganizing or optimizing internal without affecting the user queries. So whichever user required on that time, we can easily change the data, modify the data, and handle the data whenever the user required. Based on that, we can organize the particular databases. And suppose long-term growth. So the database can support long-time database application. Has a business needs involves, the database can update without breaking the existing system. So whatever the data is there, we don't want to change or don't disturb the present system. Again, we can also update the data or structure without affecting the present data. Present databases or database structure, we don't want to change that system. So that is the flexibility we are having in the data independence. Now, what are the types of data independence? And the data independence is able to change the database schema at one level without affecting the other level. And the schema is nothing but the structure of the database. Okay. And it helps to maintaining the flexibility, reducing the maintenance, and ensuring the applications continues to work despite the internal changes in the databases. There are the two types of the data independences. So that is generally physical level data independence, and second one is a logical level data independence. So we already see data abstraction diagram, that is also very similar to the data independence diagram. So this is the storage databases. We can call it as the databases. Okay. And this is a physical level, logical level, external level. We already see in the data abstraction. So here the data independence, whenever you are changing the data in the data physical level, it may not be affected to the conceptual level. So whenever I am changing the data in the conceptual level, that is a logical data independence, it cannot be affected to the physical level. When you are changing the both the data in the both the level, it may not be affected to the view level. Okay. If you are changing the structure, automatically it can be reflected in the view level. It cannot be affected to the whatever the existing database or data model is having. And the first one is a logical data independence. So it is able to change the logical structure, that is a tables, columns, relationship. For example, in the logical level, when I am creating the table, that is the first one, the first column, SID, student name, student ID, student name, student age. Okay. When I am creating the table, so I given only the 3 columns. After I want to change that particular table, I can add by using of the alter command. I can add one more column into the table. Okay, suppose I'm adding here the student address. Okay, it may not be affected to the present whatever the table contains the data. And we can also give the relationships to one table to the other table. Okay, and without affecting the external view or application programmer. The purpose of this allows the data structures to evolve without impacting the user access and requiring changes in the application code. So whenever you are changing this particular data, adding the data, it may not be affected to the view level. The user can easily access the data. And what is the matters here? So helps modify the structure of the database as business needs allows. See, whenever we are doing the applications, business application, the database application, there are the several applications in the Dbms. So day-to-day lives, each and every day the data is increases. We can also add some columns, delete, drop. So based on that, automatically we have to modify the data, which is necessary in the database. We can add, which is not necessary. We can also delete data from the databases. Okay. So the applications and user interfaces remain unaffected. So whenever you are changing this data, it cannot be affected to the remaining applications which is already existing in the databases. And next one, what are the examples of the logical data independence? So when you are adding the column like email, employees table, it creates a new relationship between the two tables, and the merging two tables in the view level as very easily. Suppose this particular table contains SID, SName, SH, S address. I'm adding another column here, that is a S email ID, student email ID. So another table we are having department table. Consider this is department ID, department name, and this particular department having the SID, that is the student ID. By using of this primary key in the both the table, we can access the data. When you are adding this particular email ID into the existing table, the user may also access this email ID by using of the primary key. Okay, we can also create the new relationship between the two tables. So automatically when you are adding the data, it can be access that relation also, and the merging two tables while viewing the very simplicity access. So by using of these two, we can also add the tables, joins the tables. And what are the benefits of the logical data independence? So we can easily maintenance of the application code and allows the smoother update in the growing systems. And third one, helps to support to the new business requirements without rewriting the existing queries. So whenever the day-to-day life, the business is expanded automatically, we have to add some columns and some data into the database. On that time, it may not be affected to the existing system, and we can also add new queries or new data to the databases. That is very easily and very smoothly, and it is also supported in the database. So that is called here the logical data independence. And the next level is a physical data independence. The ability to change how the data in the physical level stored without affecting the logical schema or user facing application. So here also same, if you are changing the data into the physical level, it may not be affected to the logical level or conceptual level as well as view level or external level. The purpose of improving the performances, storing effects, efficiency, hardware configurations without changing how the data is structured logically. And what is the matter here also? Enable to performing the tuning and hardware changes and did not affected to the how the data is structured or queried. And next one, what are the examples of the physical data independent? When we are moving the file from the C drive to the D drive, it's create the index to speed up the query, and switch from HDD to SSD for the better performance, compressing the data files to save the space. So in the physical level, the most thing here, we can also compress the spaces, and when we are switching from one level to another level, it can also give the better performance to the user. And when we are creating the index, we can speed up the queries, and the file we are moving from one file, one drives to the another drive, that cannot be changed as the data. And what are the benefits of we are having while using the data independence? The backend customization without affecting the user. The backup data is also customizing the without affecting the data, backend data, and reduce the need of the structural changes during the storage update and improving the long-term maintenances. When you are changing the data in the physical level, it may not be affected to the structure in the logical level. And we can also having the backend optimization without affecting the user level and improving the long-term maintenance. And next one, what are the differences between the physical data independence versus logical data independence? We already learned. Now we can see the what are the differences. So in the physical level, it is morely focusing on the how the data is stored in the physical level. In coming to the logical data independence, it focusing on the structure and organization of the data. So that is what the data is in databases, that is the tables, relational relations and their relationships. Okay. So in the physical data independence, how the data is stored in the physical level. In the logical level, what the data in the storing, what the data is there, what are the relationship it is having. And next, in the physical data independence, it deals with the internal schema. And the logical level, it can deals with the conceptual level schema. So it is completely depending on the logical schema. This is the internal schema. Schema is nothing but structure of the database or data model. The changes don't affect in the application program. When you are changing the data in the physical level, it may not be affected to the conceptual level as well as the view level. It is also same thing in the logical level. When you are changing the database based on the requirements, automatically it can be changes, but it may not be affected to the physical level as well as the view level. If you are updating any data, automatically viewer can see the data in the both the levels. It tells about the internal schema. This physical data independency tells about the internal schema. Logical data independency can tells about the physical, that is a conceptual level schema. And easier to achieve the data, it is more difficult to achieve the data, because if you know the concept about the relationship and their what are the relationship, whether it is a one-to-one relationship, one to n, many to one or many to many, sometimes it is difficult to analyze the data. Okay, that is a users, not the DBA, data administrator or application programmer. And in the data physical data independence, use it for the performance and the storage optimization. So it is mainly concepted under maintenance and storage optimization. In the logical data independence, use it to evolving database designs. So it is more concepted on the data modelings or database designs. And coming to the physical data independence, moves the data files and adding the indexing. So by using of the physical data independence, we can move the file from one drive to another drive. So I want to change my file that is in the C drive. So I want to change C drive to the D drive. It cannot be affected to the data. And also it is adding the indexing. So when you are creating the indexing, we can easily access the data wherever it is storing the entire databases. Without indexing, it is very difficult to identify the data. It is more complex. So this index concept is very useful in the database management system. And coming to the logical data independence, example is adding or removing column in the tables. So this is completely depending on the relational model or data models. So coming to the relational model, so when I am changing the table, either it is adding or deleting of the columns, automatically it can be changed and it may not be affected to the physical level as well as the logical level data and the view level cannot be affected. Okay. So I want to repeat it entire topics whatever covered in the today's session. And the first topic is data abstraction. In the data abstraction, we are having the three levels, that is a physical level data abstraction, logical level data abstraction, view level data abstraction. Physical level we can also call it as a internal level, logical level we can also call it as a conceptual level, view level we can also call it as a external level. Data abstraction is nothing but we can hide the data from the databases. So whichever users required in the database, with required in the applications or users. So automatically that data can be provided, which is not relevant to the user. We cannot provide that data. The entry can be handled by the database administrator. And the next topic is data independency. We are having again two data independency, that is physical level and logical level. So when you are changing any data in any level, automatically it cannot be affected to the already existing system data. If you are adding the column, automatically it can be added and that can be updated in the view level also. Okay, and these are the references I am used in this particular slide. Thank you.